All right, good morning, everyone. Welcome back. Finish up the week here. We're going to be continuing with rational functions. I gave you a set of problems to do for homework. We'll address that in just a moment. I wanted to just do kind of a quick recap of what the main ideas were from last class. We had started talking about what a rational function was. And I told you that a rational function was any function where you just take a polynomial and divide it by a polynomial. And then we looked at the graphs of a few of them. And even though the graphs of rational functions can look very different from one another, there's three main characteristics that we look for in rational functions. And so I wanted to kind of point those out on a sample graph, so that as we're moving through the problems today, you'll kind of be looking for these things. So the first, I guess the one part of a rational function that you should be familiar with is something called, an x-intercept. When we were doing lines, we found x-intercepts. When we were doing parabolas, we found x-intercepts. When we were doing polynomials, we found x-intercepts. So that's anywhere where the graph touches the x-axis. So what you see here is a graph of a function. The red is the actual function, okay? Everything else is either the XY axis or these dotted vertical lines are not part of the graph, but you'll see we're gonna use those dotted lines to help us kind of see what's happening with the function. So the red is the function, and notice we have those two x-intercepts right there, right? So those are x-intercepts. So rational functions may have x-intercepts. They do not have to, but they could have x-intercepts. And then there's these vertical dotted lines that I drew here. These are our vertical asymptotes. We talked about those as like vertical barriers last time. And what happens is when you draw the graph, these vertical barriers kind of force your function to go either up or down on either side of that vertical dotted line. So those are important aspects of a rational function. Again, a rational function may or may not have them, but if they do, that's kind of what they look like. So the second characteristic is a vertical asymptote. And then the last, what's going to turn out to be, I guess, the more challenging or the most challenging part of this is to figure out what is called the horizontal asymptote. Now, I have it listed here twice on this picture. What the horizontal asymptote is like that problem I gave you, or that the idea that on a long enough timeline, everything drops to zero. Remember, we started kind of the whole idea of this. We're talking about probability and how we want a function that kind of diminishes and keeps getting smaller and smaller without actually ever getting to zero. That's what this is. You can see the function drops down, gets smaller and smaller and smaller. It's getting closer to the x-axis, but it's never making it to the x-axis. And then over here, it's really hard to see this, but it actually goes below the x-axis and then back towards it. I think I have a better picture for you. Let me bring the better picture here for you so you can see this. Yeah, there we go. So here's that same graph. If you notice here, it dives down, it goes through the x-axis. So we have an x-intercept, it comes down, but then as you move to the left, I hope you can tell it's starting to go back towards the x-axis. So you see how the red is getting just closer and closer without actually ever getting there. It just gets closer and closer and closer. So the horizontal asymptote is something at the end of the functions. It's at the edges. The horizontal asymptote has nothing to do with what's going on here. It tells you everything about what happens at the edges. And I like to look at the horizontal asymptote like a magnet. When you get two magnets, you put them together and they stick together, right? Or if you hold a magnet and put a piece of metal next to it, it'll kind of pull them together. This horizontal dotted line here that I drew is kind of like a magnet. And as we draw this graph to the right, it's like pulling that red graph towards it, although it's never going to touch it. All right. So I've summarized the three things here, the three main characteristics right here. Don't worry about copying this down because I'll restate all this in a little while. So the x-intercepts, this was your homework problem, right? The homework problems I gave you. I said I wanted you to find the x-intercepts and vertical asymptotes for these four rational functions. So what you should have done for homework is you should have set the numerator equal to 0 and solved, right? And when you get those answers, when we go and look at the graph, these answers that we get are going to be points on the x-axis. So it's kind of like the x-intercepts are going to give us these points on the x-axis. And then you're going to find the vertical asymptotes. Now to do that, you set the denominator equal to 0 and solve. And so you'll get some answers, right? You did that on your homework. Those answers are not points on the graph. They are not. They are, the solutions are vertical dotted lines. So like for this problem right here, you can kind of tell that this vertical dotted line is happening at 6. And so if I would have, for this rational function, which I haven't shown you the actual function, just a picture of it. If I set the denominator to 0, 6 is a solution. And so what I would do is I would draw a dotted vertical line through 6. And then another solution, it's harder to see it here, is the solution 0. And so you draw a dotted line through the y-axis. Okay, so it's very important that you understand that when you find the x-intercepts, you're going to be drawing dots. But when you find the vertical asymptotes, you're going to be drawing vertical dotted lines. Okay, that's all from last class. That should all sound somewhat familiar. We good with that idea, those concepts? Okay. Now, the horizontal asymptotes, these, how do we find these, right? That's the question. Like, how do we get the horizontal? How do we figure out whether or not our rational function has a magnet that pulls it at the ends? I haven't shown you that yet. I will do that today. But the important aspect of I guess, right now is just to know that the horizontal asymptote, I'm going to abbreviate it with HA instead of writing it out over and over. The horizontal asymptote acts like a magnet and pulls the function towards it at the ends of the function only. So I guess you have to remember that, like I said just a second ago, the horizontal asymptote does not care what happens in the middle. Okay, you're just not even looking in here. The horizontal asymptote only tells you the end behavior. You can kind of think of it as when we were doing polynomials. Remember I gave you that table and we were checking like even and odd for the degree and then the leading coefficient, positive and negative, and there were like these 4 possibilities of what the graph could do. That only told you what happened at the ends, right? In the middle, we put a question mark. Horizontal asymptotes here are the same thing. It only tells you what happens at the ends. It pulls it towards it. It does not tell you anything about the middle. So just keep that in mind as we proceed through today. Okay, now the homework problems. Did anybody have any questions on finding the x-intercepts or vertical asymptotes for these any of these homeworks?
I did have a question on the I think it was the first one. So yes, it was the first one. So the 2x minus 4.
Yes.
So you take a 2 out.
Okay, so you're talking about this one here, and you said when you were finding the x-intercepts, you set the numerator equal to 0, and then you decided to pull a 2 out. That's fine. Like this, you factored a 2, which left you 2 times in parentheses x minus 2. Okay, I think I already know your question. You're probably going to ask me about this 2 in front.
So was I supposed to factor it out or no?
Well, yeah, you can. You don't have to. Because it's a linear equation, Emily, you could have done it like the old-fashioned way, like just like add 4 to both sides, right? And you get 2x equals 4, and then divide both sides by 2, and then you get x is 2, right? But you can still do it the way you're doing it, okay? But I guess this is where I'm curious as to your question on this, because this is okay. This is legitimate. Are you wondering what you do with the 2 out here?
Yes.
Yeah. Okay. So that's a very, very common question. Because you've created multiplication here, you're going to set each of these equal to 0, right? That's kind of the whole idea when we factor. We set each factor to 0. When we set the x minus 2 equal to 0, that one we can just add 2, we get x is 2, right? But you're okay with that, Emily? But the other one, yes?
Yes, sorry.
Okay, that's okay, it's okay. I know you're trying to unmute. But the other one, when you try and set 2 equal to 0, well, 2 is not 0, right? 2 can never be 0. So there actually is no solution from this because there's not even an x in here, right? So the only answer you get is the 2. Now, another way you could look at this, if you wanted to kind of look at it a different way, is just to do this. I could divide both sides by 2 right now, right? I mean, that's legal. I can divide by 2. The 2's would cancel here. I get x minus 2. And over here, 0 divided by 2 is 0, right? So it's almost like because you factored out a 2 and it was a number, you could always just ignore it. So at the end of the day, if you just want to kind of remember something, if you're ever factoring and you get just a number out front, you can ignore it if it's just a number, because that's never going to be 0. Now be careful, everyone be careful, because that's different than this. Watch, look at this problem right here. This is a totally different problem. If you set that equal to 0, if you factor something out here, you would pull a 2x out, right? And then get x minus 2. Do you see the difference between this and this? Here we have an x that also comes with a 2. And now when you set that to 0, yes, you will have a solution because 2 times 0 gives you 0. So you actually get an answer here. And then you get the 2 from here also. So you get 2 answers, right? But because over here it was just a 2 and there was no x next to it, then, well, 2 can never be 0. Does that help make that make sense?
Yes, it does. Thank you.
Okay, good question. Any others?
I have a question on 4.
Mm-hmm.
I was wondering when I started on the top row, I ended up taking it out. It was a 1 squared because it has an x to the 4th and a negative 25 squared. So I didn't know if that was right or not if I took out the 1 squared.
Okay, let me see. I'm not quite sure I understand. So you were finding the x-intercepts there. So you took the top and set it equal to 0.
Yes.
Okay, and then what did you do?
I was looking at it and I'd seen what could I take out of it.
Yes.
And so I did it was 1x because if it's an x to the 4th, it would have an imaginary 1 in front of it. And then you have the negative 25 squared. So you could really only take 2 of them out. And that would leave you with, I ended up getting was 1 squared and then parentheses x squared minus 25 close parentheses equals 0. And then I did it was.
John, you're saying 1 squared. Do you mean 1x squared?
Yes, I'm sorry about that.
No, it's okay. You said 1 squared. I just want to make sure because I agree with this. This is right.
Yeah.
That's right. Now you don't need the 1, but you can put it there. It's not wrong to put it there. You just don't need it. Okay. Yeah, that's right. And then from here, you saw that this was a difference of squares and that broke down to be x plus 5, x minus 5.
Yes, and then I switched them after.
Yeah, and that's okay. Yeah.
Okay, cool.
Now you set them each equal to 0. You should get 3 solutions. 0, 5, and negative 5.
Yep. Okay.
Good. Okay.
And for the bottom one, would it be 3x minus 5 for question 4? Sorry.
Yeah. No, for question 4, you're setting
3x minus 5 equals 0, and then would you move the 5 over and divide it by 3 to get 1.6?
Yep.
Okay.
Yeah. So this was the only one. Yeah, this was the only one in the entire set of problems I gave you. This is the only one where your answer was a fraction. I kind of just wanted to see what you would do. So to find the vertical asymptotes on 4, you take the denominator, set it to 0. So yeah, here it's a linear equation. You can add 5 to both sides, and then you can divide both sides by 3. And you can leave it like that, or if you wanted to, you could get a decimal. You said it was like 1.666 or something.
Yes.
To repeat it, it doesn't matter. You can just round it to 1.67 or 1.7. That's fine. Okay. So if you did your homework, which sounds like a lot of you did, then you've already done a lot of the work that's required to graph these, all right? The thing that's missing right now is we still don't know how to find the horizontal asymptotes. Like that's the thing I have not shared with you yet, right? I've not figured out, or I've not told you how you find whether, first of all, whether or not you have a magnet at the end, because you don't have to, but if you do, how to actually find it, all right? Once we have all three of those elements together and have a way of getting all of them, then we will be ready to try and graph, all right? So right now, what I want to do is talk about how to find the horizontal asymptotes. Hey, before I do this, I wanted to discuss something about our schedule with you. So I'm pretty sure I've told y'all my wife's had some medical issues over the last, I don't know, are y'all aware of that or no? No?
Yeah, well, you said that she was sick.
Yeah, that's what you mentioned, yeah.
Okay, yeah, so she's been battling something for about 4 years now. So we think that we may have found the issue, but it's going to require a surgical procedure that's going to have to be done in Houston. So we have a date for that, and I know it's going to impact one of our class meetings. So our schedule here, let's see, because we're way off on this schedule, but I'm just going to tell you the date is going to be November 11th. This class, November 11th, just kind of mark it on your calendar. I'm not sure how I'm going to handle that day's lecture. That'll be the day of her surgery, I believe. Yes, I need to double check. That might be the day before. Anyway, either way, I most likely won't have our Zoom meeting that day. So we have two options. I can get a sub to come in, which would be just some other person coming in and doing a Zoom session for me, and they would cover whatever I was supposed to cover. That would be option one. And then option two would be, I have over 2,000 videos on YouTube. So I could go find the video that I've done before on the topic that I'm covering that day, and I can just tell you all to watch it. And then when we come back the next week, I could say, do y'all have any questions? You know, that sort of thing, where you're just gonna do it on your own, but you won't be able to ask questions during class. So think about it. I don't want to know right now, but just think about which way you'd rather do it. And then what we'll do is we'll take a poll maybe next week and just kind of see what y'all want to do. And you know, I'll tell you my personal experience is that anytime I ever bring a sub in, I always have to go back and explain things, because they're going to do it different. They're going to have a different sort of approach, you know. So I always have to re-clarify. So I always lean towards I'll give you a video and then answer questions later, but it's ultimately your choice. I'm happy to have a sub come in. Okay. So just FYI. All right, back to this here. All right, so how to find the horizontal asymptotes. So this is the most complicated part. All right, like I said, I think this is the most complicated part. So what it is you're going to take a look at remember you have a rational function, right? So you have this rational function. I'm going to write it down. It is a polynomial divided by a polynomial. Let's just remember what we're doing here. What you're going to do to figure out the horizontal asymptotes is you're going to look at the numerator. You're going to find the degree of the numerator. Now, what do I mean degree? What's the degree of a polynomial? What is the degree?
The highest power in the equation.
Yeah, the highest power of x, right? So you're going to find the degree of the numerator, and then we're just going to call that capital N, all right? It should be a number, right? Maybe it's 2, maybe it's 3, maybe it's 4. Hopefully it's not past 4. And then what you're going to do is you're going to find the degree of the denominator. And we're going to call that capital D. Capital N for numerator, capital D for denominator, right? So that should be two numbers, right? You should have two numbers there. And they don't necessarily have to be the same, do they? Right? They could be different numbers. I'm going to go and look at our homework. I'm going to give you another second to copy this down. But on the homework, we could already do this right now, right? We could identify what N and D are for our homework. Let's look at these. So for number one, what would capital N be for number one? So what's the degree of the numerator here?
2.
2. Nope, careful. Look at the numerator here. What's the highest power of X?
1.
1, right? There's a 1 right there on that X. So N would be 1. And then what would capital D be? So look at the denominator. What's the highest power?
2.
2, right? Understand? 2. Over here, what would capital N and capital D be on these?
2.
2 on both, right? This would be 2 here and 2 here. They both have powers of 2 here, highest powers. And then on number 3, N would be 2, but D would be 3, right? So that's 2 and 3. And on the last one, N would be 4, and here D would be what, 1, right? Because the power on X is 1. What do you think? That's pretty straightforward, right? You're just looking for numbers. It's not too bad. So when you get those numbers, the question is, what do you do with them? And what do they tell you, right? That's kind of like the ultimate thing here. So think about this. If you have two numbers, what are the 3 possibilities that could happen between those numbers? They could either be the same number, right? Or one of them could be bigger than the other, or one could be smaller than the other, right? So you can either have the numerator, like look at this one, the numerator is smaller than the denominator, right? Here, numerator is smaller than denominator. Here, they're the same. Here, the numerator is bigger than the denominator, right? But those are the only 3 possibilities. One of them is bigger than the other, one of them is smaller than the other, or they're the same number, right? That's it. So those 3 scenarios will dictate exactly what happens, all right? So here we go. If capital N is smaller than D, then Y equals 0 is your horizontal asymptote. Now, keep in mind what Y equals 0 means, because right now you're like, what? Y equals 0? What is that? Y equals 0 is basically a horizontal line, right? We did this when we were talking about lines. We said if we ever see Y equals a number, it's a horizontal line. If we see X as a number, it's a vertical line. So this is a horizontal line. In this particular case, it happens to be the X-axis. Do you all agree with that? If I told you to draw the line Y equals 0, you'd basically draw a line through the X-axis, right? If I said, hey, graph me Y equals 0, it would be this horizontal line right there, right? That's what happens if the numerator is smaller than the denominator, then Y equals 0 is going to be where your magnet is. Now, the next case. If the numerator is, I'm trying to decide which one I want to do first. Let's say they're equal. No, let's go greater. If the numerator is greater than the denominator, the degree, then you don't have a horizontal asymptote. You don't have one. Which means that your graph never flattens out. Your graph does not get pulled towards a magnet. And since it doesn't get pulled towards a magnet, that means this. It means that when you draw it, the left side could go up, or it could possibly go down. In the middle, we won't know. And the right side could go up, or it could possibly go down. So in the second case here, if the degree of the numerator is bigger than the denominator, what we know is that the ends don't flatten out. Okay, they don't flatten out, which means they either have to go up or down. Okay, and we don't know yet. It's going to be up or down on either end. We will have to figure out which one it is. It's either going to be up or down, but we still have to talk about that. And then the last case is if the numerator and denominator have the same degree, okay, they're equal, then we do have one, and here's what it is. It's y equals, so you know how the first one was just, this case was just y equals 0 is just the x-axis, that was all nice. This one, if they're the same, then it's going to be a horizontal line, but it's going to be y equals the LC of the numerator divided by the LC of the denominator. What do I mean LC? We used this before in this class a couple of days ago. What do I mean by LC? Does it look familiar?
Leading coefficient.
Leading coefficient. So when we are talking about polynomials and we did this leading coefficient test, right? We were looking at the number in front, right? Here's the degree was 3, the leading coefficient was -2. Here the degree was 4, the leading coefficient was -5. So this LC that we talked about in the past, leading coefficient is the number in front of the highest power of x. So what I'm saying here is that if the degrees are the same, then you're going to take the leading coefficient in front of in the numerator and you're going to divide it by the leading coefficient in the denominator. And this will be a horizontal line. Now, I realize that this is confusing, all right? So what I'm going to do is I'm now going to go through each of the homework problems, and we're going to find the horizontal asymptote for each of the homework problems now. Here we go. Let's take these to a different page here. So here are homework problems, and what I want us to do now is not find the x and y or x-intercepts and vertical asymptote. I want us to find the horizontal asymptote. And let's start with number 1. I'm just going to put what we get down here. On number 1, the degree of the numerator we said it was 1, and then the degree of the denominator we said was 2, right? N was 1. D was 2. That means that N is smaller than D, right? Because 1 is smaller than 2. And according to what I put here, if N is smaller than D, then we have a horizontal asymptote, right? And it's y equals 0, and we're done. So I'm going to say, okay, from this, I know that y equals 0 is my horizontal asymptote. Are there any questions on that? That's the easy case. Whenever the degree of the numerator is smaller than the denominator, it's always y equals 0, and we're happy. Let's look at number 2. On number 2, N is 2 and D is 2, right? They're both the same. So they're equal. And according to my notes here, if they're equal, then we're gonna have one. What I forgot to put is our horizontal asymptote. We're gonna have one, and it's gonna be a horizontal line. It's gonna be y equals the number in front of the highest power of x on the top divided by the number in front of the highest power of x on the bottom. So for us, we know it's going to be y equals. Now, what is the number in front of the highest power of x on number 2? What's the number?
1.
1. And then what's the number on the bottom in front of the highest power of x?
1.
1 also, right? So this will be 1 divided by 1, which is just 1. So y equals 1. If I were to ask you to, hey, everyone, go graph the line y equals 1, I hope that what you would do is draw an x and y axis, right? And then you'd go up 1, and you draw me a horizontal line like that, right? That's what y equals 1 looks like. So our little magnetic line is going to be up 1, as opposed to on the first problem, the magnetic line is actually just on the x-axis. How about for 3? Who wants to tell me what happens on 3, the third problem? N is 2, D is 3, right?
Y equals 0.
Y equals 0, because the numerator's degree is smaller than the denominators. And that's that first case, that's y equals 0. And then on the fourth one, the numerator is 4, the degree is 4, and then I always have problems saying, and the denominator is 1. In this case, the numerator's degree is bigger than the denominators. And what happens when that happens? If the degree of the numerator is bigger than the denominator?
Then you don't have, oh yeah.
Yeah, we don't have one, right? We don't have one. So that's going to tell us that the left side's going to go up or down, the right side's going to go up or down. So no horizontal asymptote. Okay. Y'all doing all right? Now, keep in mind that on your next test, I will allow you to have a cheat sheet, a reference sheet, and you'll be able to put all these steps on here. You'll be able to put, you'll be able to write all this information on the formula sheet, so you'll have it. Okay, I'm not going to expect that you memorize all these 3 cases and stuff, right? You'll be able to go back and look at it. So just keep that in mind. Okay, so I think I'm ready to actually start to see if we can't graph one of these. I'm not done, okay? At the end of this, I will give you a final set of steps. Like, here are all the steps. I will do that, but we're not quite ready for the steps yet. I want us to see what we can do with what we've learned so far. So I'm going to take this first function here, and I'm going to see, can we sketch this? Do we have enough information to sketch this? So the task here is for us to try and sketch this. Try to sketch it. Okay. So let's go through some things we know, right? So like the first thing I know is the x-intercepts. That you can get by setting the numerator equal to 0. And if you did your homework, you should have got that x was 2. The other thing I know is that I can find the vertical asymptotes. That was your homework, right? And for that, I set the denominator equal to 0. And who wants to tell me the solutions they got here?
0 and 6.
0 and 6. Good. Now, if you didn't do your homework and you don't know how to get those answers, you need to go figure out how to get those. You're just solving those equations. All right. So I'm just keep in mind, I'm not showing that work. Normally, if this was a brand new problem, I'd show that work. Okay. The third thing I'm going to figure out is where the horizontal asymptotes are. So we did this just now, didn't we? We talked about this a minute ago on the previous thing. We said, hey, on this first problem, right? If we're trying to find the horizontal asymptotes, the numerator is 1, the degree is 1, the degree of the bottom is 2, and so n is less than d, so y equals 0 is the horizontal asymptote. So here n is less than d, and that tells me that y equals 0 is the horizontal asymptote. All right. Any questions on what we've done so far? We're all okay, comfortable with that? Let's see if we can draw this right now. I'm going to see how much is what I have right now enough to draw the picture. All right. So to do this, here's what I'm doing. I'm just going to draw an X and Y axis. Okay. And let's start with the first thing I know. I know I have an x-intercept at 2, right? I have an x-intercept at 2. So if I go out 1, 2, I know I have an x-intercept. So I'm going to do this in a different color so that you don't mistake it with something else. That red dot is on my graph for sure. Agree with me on that? I have an x-intercept there. Now, the next piece of information is that I have vertical asymptotes. I have 2 of them at 0 and at 6, right? 0 and 6. These are not dots, right? These are not part of my graph. These are those vertical barriers. So what I'm going to do, I'll switch colors. I realize you don't all have colors, but 2, 3, 4, 5, 6. I'm going to go out to 6. And right here, I will draw a vertical dotted line. And then I need another one at 0, don't I? But see, it's hard to draw a dotted line on top of a solid line, right? Because we already have the y-axis there. So my students in the past have done this. They've said instead of drawing a dotted line, they draw like a dotted line, but like kind of like tilting over the dashes so that you can see it a little easier. Right now, I only have 1 point on the graph, right? This point exists. Other than that, I know I've got this wall and these 2 walls, right? These 2 barriers that force my function up or down. The last thing I know is that I have magnet. I have a magnet, right? I have this magnet that's at y = 0. Now, don't draw this, but y'all agree y 0 is this, right? Like that, across. But remember what I said. The horizontal asymptote only tells you what happens at the edges, right? Only at the ends. So I highly recommend, in fact, I get kind of upset when students don't do this, that you just draw y = 0, a flat line, but just don't draw the middle of it. Just go out to the edge. So I'm going to draw a dotted line horizontally this way and a dotted line horizontally this way, because that tells me this dotted line, I have to get closer to it. That's my magnet. That's going to pull me towards it, but only at the edges. The danger is that if you draw this dotted line all the way through, it's going to create problems for you later. You're going to think, oh, I can't go through that, and it's going to mess your graph up. Trust me, trust me, trust me, all right? Just draw it at the edges. Okay, now, the question is that enough to draw the picture? What do you think? Can I draw it just with that?
No, because I think you have to like figure out which way it's going.
Yeah, there's a lot of unknowns here. Like, let me just draw something for you and you tell me whether or not you think this would satisfy everything that's here. Don't draw this. Would this be okay? Could it do this? Could it flatten out towards that, get pulled to the magnet, start going this way, and then here's this barrier, so it decides to go down like this. Maybe I'll extend that. So far, does this satisfy what needs to happen? Does it get pulled towards that? Yes, right? Does it, it doesn't go through this wall, so it drops down, right? So that is, so far, it looks like it satisfies everything it needs to satisfy. Over here, I need to go through this point. So could I do this? Make it go, oh, I need the same color. I'm gonna do blue. So could I make it go up like this? And then over here, just kind of curve it and make it go like that. Would that do what it needs to do? Does it go through here? Does it have an x-intercept? Does it go up over here and down over here? Right? It doesn't go through the walls. And then I could do this. On the other side, I could do kind of the same thing. I can make it go like this. And then get pulled towards that magnet like that. And that right there, I have not violated anything that we knew, right? We knew where the x-intercepts were, we knew where the verticals were, we knew where the horizontal magnets were, and what I drew is perfectly fine. I mean, that's everything there, right? Oops, sorry. like to take my phone out of my pocket. I forgot. Okay. So that I could draw, nothing's violated. But then someone else in the class could say, well, what about this? What about if you drew it this way instead? And make it go up here. And then over here, they could have done something like this. They could have made it come down like this, go through that x-intercept and go up. And then they could have made it go like this. And that picture in gray satisfies all the conditions also, right? Same x-intercept, the verticals are in place, the magnets pull it down, right? So which one's correct, right? We don't know. It's like we just don't have enough information right now. Let me do another picture I could have done. One more, I'll do this one in thick black. So we could have done something like this. I could have done this. I could have made it go up over here. I could have made it come here and just bounce off the x-intercept and go back up. And then I could have, I don't know, on the other side, I could do whatever I want. I'll make it do this. Okay. All three of those graphs still satisfy the conditions that we've determined, which means that those three things are not enough. We need something else. So can anybody kind of tell me, I don't know, I'm just curious, can anyone tell me what maybe we could do to help us figure out, like over here, I don't know whether or not my graph is up here or down here, right? So what could I do to figure out if my graph's up here or down here?
Could we do the leading coefficient test?
Okay, so you're thinking, can we do what we did with the polynomials, right?
Yeah,
Figure out, and unfortunately, as soon as we get to rational functions, that leading coefficient test goes away. Unfortunately, it does. So let me ask you this. What if we took a point? Like, let's say I picked some random point over here. Like, do you agree -4 is over here? Do you agree -4 is here? What if I just took -4 and plugged it into the function? Right, we have the function, right? The function's right here. What if I plug -4 in here? It's going to give me a number out, isn't it? Some number's going to come out. And that's going to tell me where the point is. It's going to tell me whether or not that point's up here somewhere or down here somewhere. Understand? If the point's up top, then it's got to look like one of these. If the point's down here, then it's got to look like this. Is there any other thing I could have drawn over here? Could this, and let me ask you this, could this happen? Let me erase all this because it looks crazy. Could I do this? Could I make it flatten out? And then as I go over here, instead of going up like that, instead of that, could I have done this and come down? Yes or no?
I think yes.
Okay. I mean, it looks like I can do it, right? I mean, I did it, right?
Yes.
But I actually can't. Why can't I go down like that?
Because of the horizontal asymptote.
Oh, because this, I crossed over this dotted line. Is that what you're saying?
Yes, I believe so.
Okay. Okay, so that is not it. And I'm glad you said that, because that's why I don't draw the dotted line all the way through. Because if you draw it all the way through, you'll think you can't cross it. The only thing the dotted horizontal line tells you is what happens at the edges. But you're on the right track. Look, what have I created? When I've gone through right here, what have I created? When I drew it like this, what did I just create? What is that black dot?
Oh, another x-intercept.
Another x-intercept, right? But wait a minute, we only had one. The only one we had was this red one, right? So you can't draw it like this, because then you have x-intercepts that aren't supposed to exist. So you're creating things that aren't allowed. Does that make sense to everyone? Like, drawing it down is not an option to you. So the reason I'm saying that is because if we were to take this point -4 and plug it in the function and get a number right here, then I know exactly what happens here. It goes down and then it comes over here and it must go up. All right. There's no way for it to wrap back down and go here. All right. Also over here, we don't know what's happening here, right? Would it be feasible for us to think that maybe we could just take this number 1 and plug it into the function? And if it spits out a positive number, then we'll put a dot here. And now we know it must do this. And then if we take a number like, let's say over here, 2, 3, 4, let's say 4, plug that into the function, maybe that'll spit out a negative number. If it does, then we know it does this, right? And then we need another point over here. We'd have to check like 8. And then, I don't know, maybe if it comes down out over here, then we could draw it, see? Same thing, we can't cross through the x-axis, only here. I hope this kind of makes sense. The idea is this. If we just do x-intercept, vertical, horizontal, if we just do that, it's not enough information. It gives us a good idea of what's happening, but not everything. So what we're going to need now for this fourth thing is we're going to need what are called test points. Okay, you need test points. And how many of them you need depends on what your graph looks like. So here comes the fourth step. So I'm trying to decide how I want to do this. Let's find some test points right now. Let's find some test points. All right. So I'm going to erase all this. We're back to where we were when we started this. Here's where we were, right? We drew these three things. There was my x-intercept, my two verticals, and my magnet at the edges. Now come the test points. So I need one test point to figure out what's happening. To figure out what's happening over here, I need one test point. And that test point would be what? Anything over here. So someone want to give me anything over here?
-1.
-1. What else would work?
-6.
-6. What else? Right. It's up to you. Okay. Just as long as it's to the left of this dotted line, that's enough. You want to do -1, do -1. You want to do -6, do -6. Here's what I can tell you. Don't do 4. 4 is over here. If we're looking over here, we want a test point like, let's go with -1 is the first one that someone mentioned. Let's go with -1. So I'm going to put it there, put -1 here. I'm going to circle it. And then down here, I'm going to put my first test point as -1. That should tell me what happens over here. Now I need to know what happens in this little region right here. What's happening here? So what's a good test point for here?
1.
1. That's probably the best test point for that because you're looking for something between 0 and 2. So 1 will be a test point. The next region I need is this region right there. I need one test point in here. So what do you want? We have some good choices.
3.
3, okay. We could have used 3. We could have used 4. We could have used 5. We could have used 3.267. Doesn't matter, but it makes more sense to pick a nice number, right? So let's pick 3. 3 will be a test point. And then final region is everything over here, right? So anything over there that I want, I'll just go with 8. If I wanted 10, I could take 10. If I wanted 9, I could take 9. 7, fine, whatever, totally up to you. Are you starting to get a feel for why graphing rational functions are the most complicated functions out of all the functions that we do? There's just a lot involved here, right? All right, so now what do we do with these test points? We are going to take our original function and we are going to evaluate the function at those test points. In the original function, if you have forgotten, it's right here. been so long since I put that there. Okay, so now I'm going to plug in. So I'm going to plug in here. I get 2 times -1 minus 4 over -1 squared minus 6 times -1. So we're just replacing all the x's with -1s. Up top, I should get -2 minus 4. On the bottom, when I square 1, I should get 1. And then when I subtract, when I multiply these together, I should get +6. So I'm going to be adding 6. You get -6 over +7. All right. So what this means is that when we plug in -1 into this function, it spits out a negative number, doesn't it? Right, we plugged in a negative and it spit out a negative. So what I'm going to do right now is I'm going to go back up here. I'm going to get these blue boxes out of here. All right, this is where we were. What I know is when I plug in -1, it gives me a point that's where? Above or below the x-axis?
Below.
Below, right? Now, how far down it is doesn't matter, okay? Because this is like when we were drawing the polynomials where we didn't care how tall, like where the humps, how tall and how high and low they went. Same thing, this is a rough sketch. So what I'm going to do is I'm going to go -1. I'm just going to go down. I'm just going to put a dot here, okay? That dot is part of my graph. It's below the x-axis, and that's all I need to be able to draw the rest of this. Now we need to do the same thing for each of these. So let's plug 1 in. This is tedious, right? I mean, this is tedious. Okay, 2 minus 4, it's -2 on top. On the bottom, you get 1, take away 6. So you get -2 over -5. And hey, everyone, I don't really care what it is, but it's a positive number, right? A negative divided by negative is positive. So what that means to me is when we go right 1, the graph should spit out a positive number. So I'm going to put a dot up here. Again, I don't care how tall it is. I don't care how high it is. I'm just going to put it up. What do you think is going to happen at 3? Think it'll be negative? I have bad news. You have to check it. Students always ask me if we just get the first one, then can we just assume that it's just going to switch signs each time? Like go from negative, positive, then back to negative, then back to positive. And the answer is no. You have to check, which sucks, but you know, it is what it is. All right, so 6, take away 4, we get 2 on top. On the bottom, you get 9, take away 18. So this should be 2 over -9. This is a negative number. So it did switch. And this one, when we plug in 3, we do get a negative number. And then 8. I'm not going to show the work, but when you do 8, you should get positive. Okay. These problems are going to take a while, aren't they? Aren't you starting to, you get that feeling? Like, look, it's 10:24 right now. We're like almost an hour into class. Okay. Questions on the idea of test points, how to get them, what you do with them, how you get a point, how you plot these points from them. Any questions on that? Okay, now at this point, you have enough information. You can now graph it. Okay, we just have to think through it. So the way I like to do it is, you know, imagine you're back in kindergarten, you're asked to connect the dots, really is what you're going to do. But you have to play by the rules. Okay, so I'm going to start with this first dot. And for every dot I have, I need to draw it to the left and to the right. So as I draw it to the left, I start drawing along here. Please don't draw this, okay? I'm going to draw along here, and then I say, oh, there's a magnet. I need to go up to that magnet, right? But since I know that, I'm actually going to make it look a little better. I'm going to make it kind of go up like this. When I draw it to the right, I'm going to try and draw this to the right like this. But as I try and draw it to the right, there's a barrier in my way. And that barrier is going to force me to either go up or down. So I either have to go and turn up like that, or I have to turn down like that. Which one is it? Is it a guess? Do you get to choose? Which one does it have to be? And why?
It's
Go
down.
down
Goes down.
Sorry.
Why can it not go up?
because it's touching another point on the x-axis.
That's right. You will create an x-intercept if you go up, and you're not allowed to create an x-intercept. There aren't any x-intercepts except this one. So you cannot go up. So you have to go down. So that means it's going to go like this. Okay, we've got the left side of the graph drawn. Now we need to draw this middle portion. And as I look at these 3 points, and I'm back in kindergarten, I can connect these 3 points together, right? I mean, that's just like, there's nothing in my way. I just connect them together. But as I draw from this point to the left, I'm trying to draw it this way, right? There's my barrier. It's got to force me up or down. And which one does it have to be? Does it go up or does it turn and come back down?
It has to go up.
Has to go up, right? Because again, same idea. You've created an x-intercept that doesn't exist. And then as I draw to the right, I'm trying to draw out this way. There's a barrier in my way. I can't go up. If I go up, I'm going to create an x-intercept. So I've got to go down. So I'm going to try and make it look like this. There we go. I'll extend that dotted line out a little bit. And then I go to my last point, and I think about this. To the left, I'm going to have to turn up. And to the right, I'm going to have to get pulled towards the magnet. There it is. So look, in this class, I mean, we all know, we've talked about this, that, you know, we're not going to be, y'all aren't going to be going on and doing more math, right? So, you know, and you'll definitely never be graphing a rational function in your life, I don't think. I'm pretty sure that won't happen. So, you know, keep in mind that we're learning this not because you're ever going to need to do this. This graphing rational functions requires a lot of things be organized in your mind, right? You got to keep a lot of things in order, and you've got to make sure you're meticulous and you don't make little mistakes, right? That's what this is about. Like, can you follow through some procedure? It's pretty long procedure without making mistakes, right? We're just trying to get that part of your brain trained here. And that will translate into, you know, whatever you do decide doing, just the fact that you've at some point in your life had to think this way, where you're being very analytical and being very procedural, is the benefit of this. So just keep that in mind. I know you'll never need to do this exact thing. All right, we ready? Final thing, I'm going to give you the steps. Okay, I'm going to give you the steps. Do we want to look at the graph of that just to confirm? Let's just look at that graph and confirm that that's what it looks like. So we have, it was 2x minus 4, correct me if I'm wrong, over, what was it, x?
X squared minus 6.
6x, right? That was the graph?
Yeah.
Okay, there it is. So there's the graph from the computer. And here's our graph. Come on, what's going on here? There we go. I mean, of course, the computer's got a very pretty, very accurate graph, but our graph tells you everything that this graph tells you, right? To the left of the y-axis over here, you should flatten out to this and you should dive down. That's what happens. Flattens out, dives down. When you're between 0 and 6, at 2, you should have an x-intercept. To the left, you should go up. To the right, you should go down. And then over here, past 6, you're going to have this going up and then flattening out. I mean, we've got all those characteristics in a nice graph. All right, here we go. The steps. Okay, how to sketch. So here's what I won't cheat. Okay, we'll just start from scratch. Okay, so final steps. How to sketch rational functions. First step, find the x-intercepts. Have we already talked about how to do that? Yeah, right. You set the top equal to 0, right? Solve it. Next thing you do, you find the vertical asymptotes. How do we do that? Set the denominator to 0, right? Next thing you do, find the horizontal asymptotes. I gave you the steps on how to do that today, right? You look at the degree of the numerator and denominator, you compare them, right? And there's 3 different scenarios that can happen there. After you do that, those 3 steps, the next thing you're going to do is plot all your information, all the info from steps 1 through 3. Okay. So all this 4th step is where you're actually going to go draw a picture using everything you just learned in the first 3 steps. So we draw that picture. What comes next after we draw that picture? What are we going to need to do?
You find the test points.
Test points. Okay. So now we do our test points. And I always have students ask me, how many test points are we going to wind up with? Like, how many will there be? I can give you some advice on this. You will always have 1 more test point than the number of x-intercepts plus the number of vertical asymptotes. Now, that may not make sense. I'll let you write it down. That may not make any sense at all to you right now. But I'll go back and look at the problem we just did, and I'll try and clarify that. So if we go back to this problem that we just completed, how many test points did we wind up with? We had
4.
We had 4. Okay. How many x-intercepts did we have? We had 1 x-intercept, right? How many verticals did we have? 2, right? So total those together, we have 3 total, right? We have 1 x-intercept and 2 verticals, 3. That means once I know that, I know I'm going to have 4 test points. It's always 1 more than those 2 together, right? So if you had 2 x-intercepts and 2 vertical asymptotes, then you should have 5 test points. Make sense? If y'all are getting a headache, that's normal at this point. Okay. Test points. Okay, so once we do our test points, right, we get them and we plot them. What do you do now after you've got all the information plotted and everything?
You draw the graph.
Yeah, you draw it, right? You draw it. But you have to be careful, right? You always have to be careful on this step to follow the rules, right? Follow the rules, right? If there's a magnet, you better get pulled towards it. If there's a vertical asymptote, you better go up or down next to it. Don't create x-intercepts that don't exist, right? Things like that. Okay, it is 10:36. I have maybe enough time to do one problem, like maybe, and it's only because we've already done a few. So let me go to the second problem that you had for homework. Here it is. And let's try and sketch this one. Okay, first step, the x-intercepts, which you did for homework. Did anybody get those? You set the numerator equal to 0. What did you get?
-1, 7.
-1 and 7. Okay, I agree. So everyone, I'm not showing this work, right? I mean, if this were a brand new problem, there's a whole set of things I need to do here. Okay, the second step, I need the verticals. So to do that, we set the denominator to equal to 0, and you should have got 2 answers there also. What were they?
2 and 4.
2 and
negative.
4. One of them should be negative.
Yeah, -2.
Yes.
-2 and +4. Yes, that's correct. Okay, third step, horizontal asymptote. We did that also, right? We did that earlier today. We did that when we were talking about the horizontal asymptotes. On that third one, we said the degrees were, oh, sorry, not the third one, the second one here. We said the degrees were equal. And when they're equal, that was that crazy case where you had to do the leading coefficients, 1/1. So we should have a horizontal asymptote of 1. Can someone tell me right now, real quick, how many test points I'm going to have?
5.
5, because I have 2 x-intercepts and 2 verticals, so I'm going to have 5. When you're thinking test points, you ignore the horizontal. This doesn't matter. The number of test points will be 1 more than the total number of these we have. Okay, good. Fourth step, I'm going to draw a picture. I'm going to draw it down here. All right, starting out with the x-intercepts. I have an x-intercept at -1 and at 7. I may have drawn this too big. I'll keep going. All right, that's 7. I have x-intercepts there, which are dots. Those are part of my graph. Those are the only places I'm ever allowed to touch the x-axis. Can never cross through it again. Those are the only places. The verticals I have are at 4 and at -2. So 1, 2, 3 here at 4 and at -2. And those are my vertical barriers. So they look like this. Right? And here's the one that always gets people. The horizontal asymptote is y = 1. So what I'm going to do is go to my y-axis. I'm going to go up 1, and I am not going to draw a line like this. I'm not going to do that. I'm not even going to draw a dotted line all the way through like that. I'm not doing that because that's going to mess me up. The horizontal asymptote only tells me what happens at the edges. So I'm going to go up 1, but I'm going to go out to the edge pretty far here, and I'm going to draw my magnet out here. And then I'm going to do the same thing on the other side. I'm going to draw my magnet out here. There we go. That's the basic picture of what I have right now. Questions? Test points. Can somebody see where the test points need to be? I need something over here, right?
Like a -3.
-3 would work. So the way I like to do it is this. I like to mark the test point, -3. And I like to circle it just so everyone knows that's a test point. Also, make sure you don't put a dot at -3. What would happen if you put a dot here?
You've created an x-intercept.
Yeah, you would confuse yourself later when you're trying to draw it. You'd have point, just test points is step 4. I'm sorry, this was step 4 was the plot. Step 5 was the test points. And the first test point we said was -3. I like that. -3 will take care of this region. Now this next part's tricky. Do y'all see where the next test point needs to be? We need 5 of them.
Would we have to do like -1.5 or?
Yes, yes, this one's gonna suck. So here's the thing. We don't know what's happening in this little region right here. Okay, so it's like we had all that over there. We got that one for that. We need to know what happens between these two. Like, does it go up here or does it go down? We don't know. So we need something in between. And yes, that's going to be a decimal. That's going to suck. Okay, -1.5. I should circle that. Yeah, I was trying to not have decimals, but we have them. Okay. All right, where next?
0.5?
2.
0.5 or -0.5? What do you
Oh,
say?
well, we could do 2 or 1.
Yeah, so look, the next region is just between here and here. Don't let that y-axis mess you up. All I need to know is whether or not, as I move to the right, if I'm going to go up here or if I'm going to go down. Right? There's no barriers in my way until I get to here. So I heard 2. 2 will work. One more. Something in this region. Oh, wait, no, not, we only had 3. Sorry, 2 more. Lost count. We need something between here and here now, don't we? Maybe 5. And the last one, anything to the right of 7. How about 8? This sucks, huh? There you go. We've got to plug each of those into the function and figure out whether or not we get a plus or a minus. Okay. So I'm gonna save us some time here. I'm just gonna show you what happens. If you plug this in, you get a plus. If you plug this in, you get a minus. This you get a plus. This you get a minus. This you get a plus. Okay. I'm just gonna save us the time. I'm gonna put a point here because at -3 I get a plus. At -1.5 I get a minus. At 2 I get a plus. At 5 I get a minus. And at 8 I get a plus. What I'd like for you to do for homework is try and draw this now yourself, okay? See if you can draw this correctly. And then what I'd like for you to do, in addition to that, is I'd like for you to try and do 2 of these problems on your own from start to finish, all right? The first problem I want you to do, I'll put that back up there, don't worry. The first problem I want you to do is the 3rd problem from the homework. Okay, I want you to do that one. And you've already done a lot of the work for this, right? A lot of this has been done so far already. The 4th problem is just one I'm going to make up for you, just on the fly here. So the next one I want you to do is keep it. I'm going to keep this pretty straightforward. I don't want to make it too complicated. Let's go 5x plus 8 over x squared plus 5x. There we go. Okay, so for homework, please finish drawing this graph. Then go do this problem from start to finish, although you've already got a bunch of that work done. And then do this one you know, using the 6 steps we have now. What do y'all think of this? We're out of time. What do y'all think? This is, you feel like you understand what you're supposed to do? Are there any like
Seems
major
doable.
questions? It's what?
Seems doable.
Yeah, doable. Okay. Just take your time. Be careful. Because if you mess up one little thing, right? If you get one like vertical asymptote off, everything else is going to be off, right? So just take your time through the solving the equation parts. All right, do your best. Have a good weekend. I will see you all on Tuesday.
Thank you.
Thank you.
Thank you.
Okay? Have a
Thank
great
you.
one. You
I had
good,
a
John?
quick
Yeah.
question.
Yes.
So for number 1, when we had ended up solving it, the bottom part, I'd messed up where it was to drop to 0. Now I know I'd like with the previous problems where you have to bring that down. But I know I'd gotten +6, -6, but when we graphed it, we didn't do the -6 on there, did we?
Where are you talking about? I'm
For the last homework, it was f of x equals 2x minus 4, and then the x squared minus 6x.
Yeah.
So on the bottom half, I ended up doing the +6 -6 because you got to get
Oh,
the
yeah. Okay, I see what you're saying. So you're saying on this one, right? Still sharing, right? Yeah.
Yeah.
So on this, you're saying that you did like an x plus.
6 and then -6.
Okay. All right. So there's a couple things that why that won't work. First is that whenever you factor something, you always have to look for GCF. And these both have an x in them, right?
Mhm.
So the x comes out, you're left with x minus 6. Okay, that's the first thing. You do that, and then that's it. You're done. But the other thing is, well, you have to set them equal to 0. You get 0 and 6. But the other issue is that difference of squares means that this thing has to be something squared also. Like when I put x squared minus 4, let's say, that's x plus 2x minus 2. So 4 is a perfect square. It's 2 times 2. So I put 2 here and 2 here, right?
Mhm.
And then it's just x and x. Here, x and x. I agree with that, but this is not a perfect square. Like, so even if it was 36x, then this still wouldn't work because this is a perfect square. So yes, it can be 6 and 6, but the x creates a problem. In the formula, there's no x's here. See that? So the way to go about this one is GCF.
Okay. Greatest common factor.
Yeah.
Okay.
Yeah.
All right.
On
Thank you.
on number 3, did you do 3 right? So when you do 3,
Yeah.
x
For
cubed minus 9x, you pull out an x, right? And you get x squared minus 9.
x squared minus 9. The second part. Yeah, I did that. I pulled out the x.
Mhm.
And I ended up getting it was -3 and +3, but
Mhm.
I brought down the 0. Yeah.
Exactly. So that one, see, this one is difference of squares because you have a 9 here. 9 breaks down to be 3 and 3. So that works.
Okay.
Hope that makes sense.
Yeah.
Okay.
Alrighty. Have a good
All right,
weekend.
cool. All right. You too.